Welcome back to the Senior Power Channel. In the previous episode, we talked about what happens when you're stuck with a mini model. You know, those small, cheap, fast versions of AI, and how to get real value out of them instead of letting them wreck your work. Today, we're going to do something a little different. I want to talk to you about something even more unsettling. And that is what happens when the model itself changes under you and no one tells you. Have you ever been building something with AI, code, workflows, content, and so forth, and suddenly thought, this used to work? Why does the AI feel so much dumber all of a sudden? Guess what? You may not be imagining it at all. Behind the scenes, the system may have quietly switched you from a full-strength model to the mini, or swapped in a new version with different behavior. Same interface, same branding, but a completely different brain. Well, in this episode, when the model changes under you, I want to talk to you about how that plays out in real projects. Explain why silent model swaps are so dangerous, especially for serious tools, and share some practical ways to protect yourself if you're building anything real on top of GPT-style models. Let's start with the story you've probably lived in some form. The long build, the almost success, and then the sudden collapse. Let's start by talking about the almost there, then crash pattern. Here's the pattern I've seen and that people keep reporting. This is firsthand, my friends. You're building a complex AI-powered system, maybe, an internal decision support tool, a workflow assistant for a hospital or clinic, an operations dashboard, or even a sophisticated web app that leans on AI for parts of its logic. You're working with a really nice, strong model. You iterate on architecture, you refine the flows, you tweak the code, and it feels like a very capable collaborator. You bring the domain knowledge yourself, along with your own constraints. It brings speed and pattern matching. You reach a point where realistically you can get a working version of the whole system in a day. Thousands of lines of code of focused building with that full model. Well, and then right as you're close to the finish line, something changes. The behavior shifts. Responses get sloppier. It stops following precise instructions. I know you didn't change your prompts, but suddenly the AI can't keep the architecture in its head, starts contradicting itself, struggles to maintain state or consistency across files. And when you ask for a small refactor, it quietly breaks and deletes key pieces. In some scripts, people have even watched it help push changes that overwrite a live app or configuration, so the working version in production is replaced with a broken one. This happened time and time to me. I can attest for this personally. From your point of view, it feels like yesterday this thing was good enough to co-build a full system. Today, it can't get even one command correct, and no one told you or me what changed. It's like working side by side with a brilliant senior engineer for weeks, and then one morning, without warning, someone swaps in an intern who's only skimmed a tutorial but keeps wearing the same badge. I'll tell you something. That's not just annoying. For real systems, especially in healthcare, finance, or any high stakes domain, it's genuinely unsafe. I think that we've pretty much identified the problem. But why is it so dangerous? Why is this silent model swap so dangerous? And why is it such a big deal? Because from the outside, almost nothing looks different. You still see the same chat interface, the same product name, which I find very interesting. Nothing changed in the product name. The same, you're talking to an AI assistant. But on the inside, the engine driving your work has definitely uh, has definitely changed. When a full model is running, it can hold more context, reason across multiple steps, follow nuanced instructions, and act as a decent partner for architecture and non-trivial code. However, when a mini or weaker version steps in, it tends to have a much shorter attention span, struggle heavily with multi-step reasoning, which of course is necessary when doing coding or system development, hallucinate more aggressively, and absolutely fail badly when you ask it to manage complex logic or multi-file code bases. And if you don't know that the switch happened, you do exactly what I did and what many people do. I'm embarrassed to say. You keep giving it high-stake tasks. Refactor the system, update this workflow, deploy that change. You treat its outputs as if they're coming from the same level of model you started with. You act on its fixes in your code, your infrastructure, or even your processes. And then days or weeks later, or immediately, you look up and your system is more fragile, more inconsistent, and in some cases, we say quietly broken. That's being nice. It's rather loudly broken. It's destroyed. So that feeling of, I didn't fundamentally change anything, but everything feels worse, can absolutely be the result of a silent model switch. Why does this thing feel so bad? Let me start with a scene you might recognize. You're working on something that actually matters. Maybe a tool for caregivers. Maybe an internal application. Maybe you're just trying to ship a feature under a deadline. You fire up the old AI and you say, hey, I need a thumbnail that shows a daughter in a hospital hallway at night with a phone in her hand, exhausted, trying to pick a rehab facility for her mom by tomorrow. It should feel tense, but not hopeless. And the mini model gives you a cheerful hallway, a vaguely concerned person, and absolutely none of the emotional reality you described. Or you say, write me a really tight intro for my podcast. My audience is caregivers under pressure, and I need to speak to that 9 p.m. panic moment. And you get something that reads like a corporate brochure. If that sounds familiar, you are not crazy. AI does not equal state, backup, or truth. One of the most dangerous side effects of this is how models talk about state. Models, especially smaller or weaker ones, will often very confidently say things like, I've saved that for you. Your app is backed up. Here is the same code as before with only the requested changes. I didn't remove anything important. But unless the product has a real system behind the scenes, actual file storage, actual version control, actual deployment logs, those sentences are just text and nothing more. The model isn't inspecting your file system, your Git history, or your Netlify account, unless some engineered pipeline is doing that and feeding it back in. It's simply predicting what a helpful assistant would say in that situation. So from your perspective as a user, the effect is the same as if it were lying. You believe your code or configuration is backed up. It isn't. You believe it applied a small edit. In actuality, what it did was it removed or rewired your key logic. You believe you can easily roll back. You can't, because you never had a real snapshot or commit. Chat history is not version control. Generated code is not a backup. And AI's reassurance is not an audit log. If you let the model sit in the place where Git backups and deployment controls should go, you're building a serious system on sand. Minis and code, or why your AI dev keeps breaking stuff. Now let's talk specifically about code, because this is where a lot of people truly get burned. I am a victim. You've probably seen the marketing. AI pair programmer. Just tell it what you want and it'll write the code for you. Everything works just fine. And then you try that with a mini model and it calls functions that don't exist, uses APIs that sound real but aren't, and gives you code that maybe compiles but definitely doesn't work the way you expect. Here's why that happens. First, limited context. Minis can't hold a big code base in their working memory. They're fine for a small function or a tiny snippet, but understand these 10 files and do a consistent refactor is way beyond their comfort zone. Secondly, they have a weaker understanding of libraries and frameworks. They're more likely to hallucinate method names, get arguments wrong, or mash up two different libraries by accident. You'll see things like using a function from version 1 of a library with a syntax from version 3, or calling methods that have never existed in any version. Thirdly, they're very confident, very confident. And on the other side of the coin, very wrong. A mini will happily output broken code in a very authoritative tone. It doesn't say, hey, I'm not totally sure this API is real. Fourth, they struggle with multi-step debugging. They can often explain an error message in isolation, but if the real problem is architectural or spans multiple files, they get lost rapidly. They can often explain an error message in isolation, but if the real problem is architectural or spans multiple files, they get lost. So how does one protect themselves with the process, not just prompts? So we're going to do a little introduction here, and then we're going to go in depth. So what do we do about this? We can't stop platforms from updating or swapping models. And all I'm going to say is that's their reality, and that's it. End of sentence. They optimize for cost, speed, and average user satisfaction. It is, after all, a business. What we can control is our own workflow. Here are a few practical protections that make you much less vulnerable to surprise model changes, whether you're working with a full model, a mini, or something in between. Put a hard wall between AI and production. Treat AI output as a draft, not a fact. Build a quick, is this a mini, sanity test. Keep your real design and prompts outside the model. And we're going to go through this now. Number one, put a hard wall between AI and production. Never let AI be the thing that directly updates your production. For apps and infrastructure, that means your live system deploys from a version-controlled repo, not from copy-paste, not from a chat window. You use branches or local copies for changes. Only you, a human, hopefully, decide what gets merged and deployed. In practice, you ask the model for a change. You pull that suggestion into your editor, not directly into your live environment. You review the diff. You run tests or basic checks locally. You decide whether it's safe. If the model suddenly starts behaving like a mini, its suggestions are just that, suggestions. They never get to silently rewrite your production system. Thirdly, build a quick, is this a mini sanity test? Check what you're talking to before you trust it with important work. You can build a tiny sanity test. You run it at the start of a session. For example, write a function in whatever language you're using that takes an array of numbers, returns only the even number, and includes 3 unit tests using your own test framework. If it can't produce valid syntax, uses the wrong test framework, ignores one or more constraints, you are likely dealing with a weaker or mini-level model. In that session, you still might use it to explain errors, rewrite comments, help with naming, or even brainstorming of scripts with checklists, but you do not give it control over your architecture or critical logic. A simple, repeatable test like that can save a lot of pain. Number 4, keep your real design and prompts outside the model. Your design lives with you, not in the chat. All the work you've done to clarify how your system should flow, what questions to ask, what safety rules apply, what output should look like, that should sit in a spec document, a prompt library, or a set of version-controlled files you own. If the platform changes models, or you move to a different provider, or you spin up a separate tool, you still have the blueprint. You're not hostage to one brittle, very brittle chat thread with one specific model behavior. What does this mean for high stakes domains? Rather critical piece of information to know. When you use AI in these domains, you already are in sensitive territory. People are under stress, making important decisions, and often out of their depth with the underlying systems. If engine driving your AI suddenly gets weaker and you haven't changed the design for that, you risk tools that give inconsistent or outdated guidance or nonsense, tools that drift from their original safeguards, tools that hallucinate or overstep into advice they should not give. That's why in these spaces it bears out the repetition of AI being a decision support, not a decision maker. Always confirm with human professionals and getting key information and commitments in writing from real organizations and clinicians, for example. We're not just trying to manage model quality. We're also trying to manage the fact that the model's behavior and entire industry can change under our feet. Well, where does this leave us now? If you're a builder, assume the model will change over time. Assume that sometimes you'll get a weaker brain than you expected. Protect yourself with version control, human review, and a hard separation between AI suggestions and a production system. If you're an everyday user, clinician, or caregiver, be skeptical of tools that pretend AI is flawless. Look for products that are honest about limitations and that push you back to human professionals for real decisions. Use AI to organize questions, draft checklists, and clarify your thinking, but not as the final word on anything critical. AI can be incredibly helpful, no doubt about it. It can also fall in ways that are subtle, sudden, and very, very real, especially when the model changes under you without warning. Our job is not just to be impressed by what these systems can do on a good day. It's to build practices and tools that stay safe on the bad days as well. If this episode helped you think differently about AI, especially about what happens when the model changes under you, please follow or subscribe, leave a rating or review, and share it with someone who's building or using. Take care of yourself. Keep asking the hard questions of humans and of AI, and I'll talk to you in the next episode. Bye.